All right, so for our first problem, we are going to have to decide whether or not this converges or diverges, and if it does diverge, then we need, or converge, then we need to tell what it converges to. So first thing we need to address is this upper bound, and I'm going to let a b take its place. And so we're going to have the limit as b approaches infinity of the integral of 1 to b of x to the negative 3/4 dx. And so we're going to go ahead and work out this portion here. So if I pull that over to the side, then notice I'm going to have x, and if I add 1, I'm going to get a fourth, and divide by a fourth, I get a 4. And I'm going to evaluate this from 1 to b. And so we can go ahead and do our limits also as b approaches infinity. And if I go sub in, I'm going to have 4, and I'm just going to let that 4 sit out there. It's 4 times, and then I'm going to have b to the 1/4, and then minus 1. And so notice if I let b be infinity, then that's going to grow without bound. So this is all going to tend toward infinity, and therefore this is going to diverge. All right, let's look at number 2. And in number 2, again, notice that we have that improper integral, so I do need to change that. So I'm going to say that the limit as b approaches infinity of the integral from 0 to b of e to the negative 2x dx. So I'm going to work on the integral over to the side, and it might be a good idea. Over here, we're going to need to do a u-sub on that if I'm integrating from 0 to b of e to the negative 2x dx. We can let u be negative 2x, so then du is negative 2 dx. And so notice that if we divide by that negative 2, then we go back and fill in. We're integrating e to the u, and then dx is equal to du over negative 2. And so we really have that negative 1/2 integral of e to the u du. And so now we're ready to come back over here and figure out what's going on with our limit as b approaches infinity of, and notice all of this will end up being negative 1/2 e to the negative 2x, because again that was what our u was equal to, and that's going to be evaluated from 0 to b. And so we have our limit as b approaches infinity of negative 1/2 e to the negative 2b, and then minus negative 1/2 e to the 0. And so on this one, that negative exponent, we are going to need to do our reciprocal. So we have here the limit as b approaches infinity of, that's going to be negative 1 over 2 e to the 2b, and then plus 1/2. So notice all of that is going to tend towards 0 as b grows without bound. So it looks like we're going to have 0 plus 1/2, which is just 1/2, and therefore this will converge. Right, for number 3, we are going to have to divide this up. So I would divide it up at 0. And so we're going to look at here the integral from negative infinity up to 0 of cosine squared x dx plus the integral from 0 to positive infinity of cosine squared x dx. And so now we need to go through and separate out this cosine, and what we can do is rewrite this. So I'm going to come down here before I set up any different boundaries, anything like that. Now cosine squared x, that's the same thing as 1 minus cosine of 2x. That is a trig identity. And so we're going to use that to do our integration, plus, and then we're going to do from 0 to infinity of the same thing, 1 minus cosine of 2x dx. Oh, I forgot my dx over here. All right, so now we need to set up those limits here. So I'm going to have the limit as b approaches negative infinity of the integral from b to 0 of 1 minus cosine of 2x dx, plus, and now we're going to do the limit as c approaches infinity of the integral from 0 to c of the same thing, 1 minus cosine 2x. All right, now let's go through and do our integration. So I'm going to have the limit as b approaches negative infinity of, and let's go ahead and integrate these. So if I integrate 1, that's going to give me x minus, and if I integrate cosine of 2x, I know I'm going to get sine back because we have our sine, cosine, negative cosine. And so if I integrate cosine, I'm going to get sine back, and I've got an extra 2 there, so I'm going to have a 1/2 sine 2x. Now you can do a u sub over to the side if you need to see that. And then we're going to have plus, and then over here, same thing, the limit as c approaches infinity of the integral, but I'm going to go ahead and do the integral, so I'm going to take that off. And we're going to get the same thing again, x minus 1/2 sine 2x. All right, so now we're ready to evaluate here. And so let's see, I need to evaluate this one from b to 0, and then this one from 0 to c. So if we do our substitution in and plug in 0, then I think that entire term there looks like it's going to drop out. So let's see, if I go ahead and evaluate at 0, I'm going to get 0, and sine of 0 is 0. So then that's going to be minus, and now I'm going to sub in b, so I'm going to get b minus 1/2 sine of 2b. And then we're going to get plus, and then over on the other side, I suspect we're going to see about the same thing. C approaches infinity. And if I plug in c, same idea here. I'm going to have c minus 1/2 sine 2c. And then if I plug in 0, that is going to go out to 0. So now looking at this, we need to try to figure out, well, what's going to happen as b approaches infinity? And so looking at this, if b is going to head out toward negative infinity or positive infinity, notice all of these things are going to shoot off toward infinity here. And so in this limit here is going to be oscillating back and forth. So really this is going to tend toward infinity. And we are going to write that this does diverge. Okay, let's look at our next problem. And so for this one, this is kind of a one-sided problem in the fact that if you notice between 0 and 1, if I plug in a 1, then I'm not going to have, I'm going to have a 0 in the bottom. So for this one, we are going to rewrite it using our limit. And as a approaches 1, and I'm approaching it from the left side of the integral from 0 to a of 1 over the square root of 1 minus x dx. So now we need to do a U-substitution. And for that, over here to the side with our U-sub, we're going to say that U equals 1 minus x So du is going to be negative dx. And so here, if we do that, then I'm going to end up integrating, let's see, a negative. We've got an extra negative there. That's going to be u to the negative 1/2. And if I integrate that, then, oops, I don't need the integration sign anymore. I'm going to need, let's see, add 1, so I'm going to get 2u to the negative 1/2, or positive 1/2. All right, so that means then that we need to come back up here and look at, and I'm going to draw a line to separate these. You're going to have the limit as a approaches 1 from the left of, and if I integrate all of that, then I'm going to get negative 2 times the square root of u, but we saw that the square root of u, and that's going to be the square root of 1 minus x, and that's going to be evaluated from 0 to a. All right, now let's go through here and fill in our endpoints. So I'm going to have negative 2 square root of 1 minus a, and then minus negative 2 again, so that's going to be plus 2 square root of 1. And it looks like here, if I sub in that 1 here, that's going to tend towards 0. So it looks like I'm going to be left with 2 times the square root of 1, which is just going to be 2. So therefore, we're going to say this does converge. Okay, for number 5, it looks like if we substitute in our 4, that's going to generate a 0 in the denominator. So what I'm going to do again is swap out that 4 for some letter, and so we're going to have the limit as a approaches 4, and this time it's going to be coming in from the left, of the integral from 0 to a of x over, and this is going to be the square root of 16 minus x squared dx. And again, this looks like we might need to do some kind of u-sub, so I'm going to go over to this side here, and if I let u be equal to 16 minus x squared, then du is going to end up being negative 2x dx. And so solving for dx, we're going to have a negative 2x here brought over. And so now we can look at our integral. I'm going to have the integral of x over the square root of u, and then dx was du over negative 2x, and so those x's will cancel. This is going to move to the outside, and so I've got negative 1/2 integral, and then I'm going to move this u to the negative 1/2 up to the top, and then du. All right, now you have negative 1/2 u, and if I add 1, I get 1/2. That tells me what I'm dividing by, which is multiplying by 2. And so it looks like I get negative u to the 1/2. All right, so now let's go all the way back up and do all of this again. So coming back over here, we have the limit as a approaches 4 from the left, and all of this integration stuff is going to go to negative u, but we saw that u is 16 minus x squared, so it's going to be negative square root of 16 minus x squared, and we are evaluating that from 0 to a. So we have the limit as a approaches 4 from the left, and if we substitute in, we're going to have negative square root of 16 minus a squared, and then minus the negative, so plus the square root of 16 minus 0 squared. And so here, if a is approaching 4 from the left, that's going to get closer and closer to 4 and the whole value is going to go out to 0. So it looks like we're left with 0 plus square root of 16. So we're going to get 4, and therefore this converges. Okay, number 6, we're going to have to do some little tricks over here to the side and try to rewrite this. If I do substitute in pi over 2 here, I'm going to get a 0 in the denominator. But what I need to do before I can do anything else with this, I need to go through and do some rewriting, because the way this form is, it's not going to be very easily integrated. So what I can do is take what I have, and I'm going to multiply the top and bottom by a conjugate. In other words, I'm going to multiply the top and bottom here by some value, and notice all of that would reduce down to be 1. So I've not changed anything but the appearance. And if I multiply this out, well, 1 times all of that is just going to give me 1 plus sine x. And then in the bottom, if I multiply this out, I'm going to get 1, and then I'm going to get plus sine x minus sine x. And then the last term is going to be minus sine squared x. And so these things cancel out, those middle terms. And so I have 1 plus sine x over 1 minus sine squared x. And then we're going to use that 1 minus sine squared x to change that to cosine x. So I'm going to have 1 plus sine x over cosine squared x. And then that is going to be useful, because then I can go through and separate this out into 2 different integrals. So here, in other words, I'm going to have 1 over cosine squared x, and then plus sine x over cosine squared x. Now that should help us in our integration part. So we're going to come back up here, and 2, I've got to stay away from that pi over 2. So I'm going to do a limit, and I'm going to say b approaches pi over 2, but it's going to be coming in from the left of the integral from 0 to b. And I'm going to use all this rewritten stuff. Well, 1 over cosine squared is going to be secant squared x, and then plus, and we can look at sine over cosine. Well, sine over cosine, that is going to be tangent, and then that would also sine over cosine times 1 over cosine, which is going to be secant. So tangent x, secant x. And I'm out of room. All right, so when we go ahead and go through this integration, we're going to have the limit as b approaches pi over 2 from the left of, and when we integrate this, if I integrate secant squared, do remember that comes back to be tangent x plus, and if I integrate tangent times secant, that is going to be secant x. And I need to evaluate all of this from 0 to b. So I'm going to have the limit as b approaches pi over 2 of, and that's going to be tangent of b plus secant of b, and then minus, well, tangent of 0, that's going to be 0. And let's see, what is the other is going to be plus secant of 0, which is 1. But we've got a problem here, because if tangent, oh, we're coming in from the left. So tangent of pi over 2, if we think about that graph again, and we have our tangent graph, well, pi over 2 is the asymptote sitting right here. And so notice that tangent can approach pi over 2, but it's never ever really going to be equal to pi over 2. This is going to be tending toward infinity here. So if I'm coming in on that left side at pi over 2, this is going to be infinity. And so that's really going to knock out our ability here to go through and develop anything. Again, secant at pi over 2 will cosine at pi over 2 0. And so secant, that's going to do 1 over 0. And if we look at that, that's going to tend toward infinity as well. So notice with these infinity parts, then that means that this whole thing is probably going to be tending toward infinity and is therefore going to diverge. Okay, if we substitute in 0 down here, we're going to have our discontinuity. So what we're going to need to do is set up our limit again. And so we're going to say the limit as b approaches 0, and that is going to be tending from the right side of the integral from 1 to b of x to the negative 1/2 dx. So we're going to have the limit as b approaches 0 from the right of, and if I integrate this, I'm going to get 2x to the 1/2, and then that's going to have to be evaluated from 1 to b. And now we're ready to sub in here. So again, we have the limit as b approaches 0 from the right of, and if I plug in 1, I'm going to get 2 times the square root of 1, which is 2, minus 2 times the square root of b. And keep in mind, b is approaching 0 here. So if I sub that in, then I'm just going to be left with 2, and therefore this will converge. Right, number 8, this is going to go back to having the idea that pi over 2, tangent at pi over 2, that's going to be talking about an asymptote. So I do need to change out that value and let that be, let's call it b. So I'm going to look at the limit as b approaches pi over 2, and this is going to come in from the left of the integral from 0 to b. And tangent squared we don't know much about, but I can change tangent squared to 1 minus, or no, secant squared minus 1. I need to flip that. Secant squared x minus 1 dx. That's going to make that a little bit easier to go through and integrate. And so here we have our limit as b approaches pi over 2 from the left of, and if I integrate secant squared, I get tangent squared x minus x, and that's going to be evaluated from 0 to b. And so we have our limit as b approaches pi over 2 from the left. And if I sub in here, notice I'm going to have tangent at pi over 2. Well, tangent at pi over 2, that's going to tend toward 0, or tend toward infinity. But let's go ahead and write it out. We've got tangent squared b minus b. There's our first part. And then minus tangent of 0. Well, tangent of 0 is still 0. Minus 0. So it looks like a lot of this stuff's going to go ahead and cancel out to 0, but here we need to talk about that asymptote as we're approaching pi over 2. Tangent has a vertical asymptote there, and so this is going to shoot off toward infinity, and therefore this is going to diverge. Okay, number 9 is going to be in your notes. That's one of the examples, so I'm going to skip that one, and let's look at number 10. Now, number 10 is kind of hard to tell what's going to go on there, so let's go over here to the side and do some factoring. We have from 0 to 2 of 1 over, and that's going to be x minus 2 times x plus 1. And here we see pretty quickly that this 2 is going to be what's going to give us some trouble. It's going to generate a 0 in the denominator. So we need to really look at our limit and let that come in from the left side. So we're going to have our limit as b approaches 2 from the left of the integral from 0 to b of 1 over x minus 2 times x plus 1 dx. Now, to integrate this, then that means I've got to come over here to the side and do some partial fractions. So over here, I've got 1 over x minus 2 times x plus 1. And that's got to be something over x minus 2 plus something over x plus 1. And so going through here, let's see, a is going to be equal to, of course, we're going to sub in a 2. So that's going to be 1 over 3. And for b, we're going to sub in a negative 1. So that's going to be 1 over negative 3. And so coming back over here, we have our limit as b approaches 2 from the left of the integral from 0 to b of, and now we can go ahead and separate this and say that's the same thing as 1/3 over x minus 2 plus negative 1/3 over x plus 1 dx. So we have our limit as b approaches 2 from the left of, and I'm going to have 1/3 natural log absolute value of x minus 2, and then minus 1/3 natural log absolute value of x plus 1, and all of that's going to be evaluated from 0 to b. Right, so we need to go ahead and do some plugging in here. And if we do, then notice that a couple of things are going to go away. Let's go ahead and do our substitution here. And if I plug in a 2, notice that here, well, let's go ahead and do our zeros too. I don't want to get ahead of the game. So we're going to have the limit as b approaches 2 from the left of, and if I plug in b, I'm going to have 1/3 natural log absolute value of b minus 2, and then minus 1/3 natural log absolute value of b plus 1. And then all of that's going to be minus, and let's plug in a 0, and plugging in that 0, let's see what we're going to get. You're going to have 1/3 natural log 2, and then minus 1/3 natural log of 1. Okay, so this whole last part here is going to go out to 0. This is a nice, neat number. However, if we're subbing in and we're approaching 2, notice once I plug that in, this is going to be tending out towards infinity here, because we're going to have the natural log of 0, and natural log of 0, if we do our graph, notice it's not ever going to hit there that y-axis. So that's going to be tending toward in negative infinity. So this here, this whole thing is going to tend toward negative infinity, and therefore it will diverge. Okay, so for our next problem, we need to change out that lower bound. So we're going to have our limit as b approaches negative infinity of the integral from b to negative 3 of 1 over x plus 2 dx. And it looks like this might be natural log. Derivative of the bottom is the top, so we're going to have natural log. So I have the limit as b approaches negative infinity of natural log absolute value of x plus 2, and that is going to be evaluated from b to negative 3. And so let's go ahead and do our substitution in. So I'm going to have the limit as b approaches negative infinity of the natural log of the absolute value of 1, which is 1, or negative 1, which is 1, minus natural log of the absolute value of b plus 2. And this looks like that's going to be 0. And then minus, and if I throw in negative infinity here, then that is going to shoot off toward negative or infinity. So this answer is going to be negative infinity, and it does diverge. Right, number 12. Let's see, it looks like if I plug in 8, I'm going to generate a 0 in the denominator. So I'm going to go through and say the limit as b approaches 8 from the left, the integral from 0 to b of 1 over the cube root of 8 minus x dx. This looks like it might be a U-substitution, so I'm going to come over here to the side and let u be 8 minus x, so then du is going to be negative dx. And so when I integrate, I've got that negative there. U to the negative 1/3 du. And so when we integrate that, we have our negative, and we're going to have u to the 2/3, so 3/2. And now we're ready to come back over here. We have our limit as b approaches 8 from the left of, and we're going to have negative 3/2 times, and then we're going to have 8 minus x to the 2/3, and this is going to be evaluated from 0 to b. Now let's plug in our 0 and b. So we have our limit as b approaches 8 from the left of, and we've got negative 3/2 times 8 minus b raised to the 2/3 minus, and then we're going to plug in our 0. So we're going to have minus a negative, so positive 3/2 times 8 minus 0 to the 2/3. And so now we're going to look at subbing in our 8, and notice here that's going to tend towards 0. So this first part is going to be 0 plus, and then we have 3/2 times, this is going to be 8 to the 2/3, which is going to be the cube root of 8 all squared. So that looks like that's going to give me 4. So this works out to be 6. So definitely this does converge. Okay, on our next problem, very similar. If we do plug in our negative 1, though, we are going to have a 0 in the denominator. So that's the part that we are going to adjust. So we're going to say the limit as b approaches negative 1. And it looks like we're going to be coming in on the right side. And we're going to do our integral from b to 0 of 1 over the cube root of x plus 1 dx. And over here to the side, looks like we're definitely going to have to do a u sub. So I'm going to let u be equal to x plus 1. And so du is going to be dx. And when I integrate this, then I'm going to have u to the negative 1/3 du. So if I integrate that, that's going to give me u to the 2/3, so 3/2 out front. So back over here, we have our limit as b approaches negative 1 from the right of, and I'm going to go ahead and put in my 3/2 times, instead of u, remember we go back to x plus 1. That's going to be raised to the 2/3, and I'm going to evaluate that from 0 to b. So now we're going to substitute in, and so we have our limit as b approaches -1 from the right of, and if I plug in 0, I'm going to have 3/2 times 1 to the 2/3, and that's going to be minus 3/2 times b plus 1 to the 2/3. And so here, as b is tending toward -1, that's going to be tending toward 0. So for this one, it looks like we're going to end up with 3/2, and therefore we are going to converge. All right, looking at number 14 here for this one. Again, let's see. From 3 to infinity, well, this problem's a mess here. Let's go ahead and adjust our upper part here. So we're going to have a limit as b approaches infinity of the integral from 3 to b of x to the -3 dx. So we have our limit as b approaches infinity of, let's go ahead and integrate there. So that's going to be x to the -2, so -1/2. And we're evaluating this from b to 3. Again, we have our limit as b approaches infinity. Substitute in our endpoints. So if we do that, I'm going to have -1/2 times 1 over b squared. If we go ahead and flip it, and then minus the negative, so plus 1/2 times 1/9. And so as this goes toward infinity, that's going to go towards 0, so that product's going to be 0. So it looks like we're going to get 1 over 18, which is kind of a strange number, but that's what we get. And this is going to converge. Okay, for our next problem, the pi over 2, that's going to make secant undefined because, again, remember that's 1 over cosine. And so what we're going to do here is change that out. So we're going to have our limit as b approaches pi over 2. It looks like it's coming in from the left side of the integral from 0 to b of secant x dx. And that secant x dx, if we integrate that, that is going to be one of those formulas. We have the limit as b approaches pi over 2 from the left, and if we integrate secant, we're going to get natural log, absolute value, of secant x plus tangent x. And then that's going to be evaluated from 0 to b. So let's come back and do those endpoints. B approaches pi over 2 from the left of the natural log. And if I sub in b, I'm going to have absolute value of secant of b plus tangent of b. And then that's going to be minus, and then natural log of absolute value of 0. Secant of 0 is going to be 1 plus tangent of 0 is 0. So that whole thing is going to throw out to 0. If we're going to approach pi over 2, this is approaching at pi over 2. That's going to be an asymptote. That's going to be an asymptote. So it looks like we're going to end up tending toward infinity, and therefore this will diverge. All right, number 16. On this one, if we sub in, let's see, they put in a t here. I think this might have been a 0. Let's rewrite this because we really wouldn't think that. Square root of x over root x. Now we've messed up the problem. Good. Let's throw in that 0. And so we're going to look at the limit as b approaches 0. And we're coming in on which side? On the right side. And we're going to integrate from b to 1 of e to the square root of x over the square root of x dx. All right, so we're going to have to come over here and do a U sub. And we're going to let u equal the square root of x, and then we're thinking about that square root of x. So I'm going to say x to the 1/2. So then du is going to be 1/2 x to the negative 1/2. And so if I rewrite that, that should take care of the square root of x that's down here in this denominator. So whenever I integrate this, that's got an extra 1/2 here. So I need to move it to the outside, and so it's going to be 2. And then it's just e to the u du. And so we're going to get to e to the u. So now let's go back over here. We have our limit. B is approaching 0 from the right. The integral from b to, nope, no more integral. I just did it. So it's going to be 2 e to the u, but u was x to the 1/2, or square root of x. And that's going to be evaluated from 1 to b. So now let's go plug in. I have the limit as b approaches 0 from the right of 2, and then square root of 1 is 1, so 2e here, and then minus 2e to the square root of b. Now, as the square root of b, as b is approaching 0, then that means this whole thing is approaching 1. So it looks like I'm going to end up with 2e minus 2, and therefore this does converge. Okay, so now we have this improper part up here, so I'm going to change that out. And so we're going to have the limit as b approaches infinity of the integral from e to b of 1 over x times natural log of x all squared dx. So U-substitution time, so let's go over to the side and say that we're going to let u equal natural log of x. Yeah, let's do natural log x. So du is going to be 1 over x dx. That's going to work out nice. So we're going to have the integral of 1 over u squared du. So if we integrate u to the negative 2 du, then that's going to be negative u to the negative 1. All right, so come back over here. We have the limit as b approaches infinity of negative u, but u was natural log of x. So negative 1 over natural log of x. And then I'm going to evaluate that from b to e. So we have our limit as b approaches infinity of negative 1 over natural log of b minus a negative 1 over natural log of e. And so it looks like here this, as that's tending toward infinity, then that whole term is going to go out to 0. And natural log of e is 1, so 0 plus 1 is 1. And so therefore this does converge. Okay, and our final problem here. For number 18, looks like we've got a couple of things we can do here with this. I would look at maybe doing a U-substitution. Now we do have our limit, our bound up here, so let's go ahead and do our limit as b approaches infinity of the integral from 0 to b of e to the x over, and I'm going to rewrite this to be e to the x squared plus 3 dx. Now over here to the side, I would let u be equal to e to the x, and of course du is going to give me e to the x dx. And so what we end up with integrating over here, we're going to have the integral of u squared right here, that's going to be u squared plus 3. So I'm going to have 1 over, because that e to the x is going to take care of that e to the x, u squared plus 3 du. And so here with that, that's looking like our inverse tangent. So with that, let's come back over here. We have our limit as b approaches infinity of, and if we work this part out, we've got our inverse tangent, but this time we don't have just a 1 here. In the past, we've had a 1, and it's been nice and neat because we could just say 1. Or x over 1, but this time it's a little bit different, so we're going to have to say it's really u over the square root of 3, and then we have 1 over the square root of 3 out front. Now those 3's were not there in previous problems because everything we looked at had a 1 there. It wasn't a 3. So when I come back over here, I'm evaluating here that limit as b approaches infinity of 1 over root 3, and then we have inverse tangent of u over root 3, and then that is going to be evaluated from 0 to b. So I'm going to go back in and plug in those b values. So if we do that, we have our limit as b approaches infinity of, and we're going to have 1 over root 3 times inverse tangent of b over root 3, and then we're going to have minus 1 over root 3 inverse tangent of 0 over root 3. Oh, goodness. All right, so b is tending toward infinity. Now, one thing we can set aside here, notice there's a 1/3, 1 over root 3. So I'm going to pull that out, 1 over root 3, so that we're just looking at our limit now as b approaches infinity. That way, try to ease some of this stuff up. And then we're going to have inverse tangent of b over root 3, and then minus inverse tangent of 0. All right, so let's see. We need to see where we're going to end up with on this portion here. If we're tending toward infinity, well, what is that going to tend toward for us? That is going to end up being a pi over 2, I believe. Because here this whole thing is going to be divided by root 3 is not going to make a difference as b is approaching infinity. So we have, oops, I had too many square roots there. So that's going to give me, let's see, at pi over 2 minus, and here inverse tangent is 0, that's going to be 0. So it looks like we're going to end up with pi over 2 root 3, and therefore this is going to converge.